Thank you. And you techs here today, congratulations. Right now in this room, you sit among some of the very best technicians the industry has ever produced. It's not just that you're good at what you do, it's good at what you do. You're good at what you do at a time when doing what you do is maybe the hardest and most challenging that it's ever been in history. The challenge is driven by the rapid changes we're seeing right now in the way trucks are built and the components they're built with. It's also in the way those components work together and in the new tools and techniques required to troubleshoot and repair them. 20 years ago, trucks were a lot simpler. A truck was an assembly of mostly mechanical parts and components, each with a discrete function. But things work differently today. New functionality has been added, and components talk to each other, manage each other, and work together as systems. According to the American Transportation Research Institute, maintenance and repair costs are up over 50% since 2008. Much of the blame for the rising costs has been attributed to the new technology for emissions. Some fleets now identify emissions-related maintenance and repair as their single greatest expense, exceeding tires. And we now have data showing emissions parts as the single largest parts category in most markets we look at. But what if the emissions technology isn't really the problem? A clean-looking battery with sparkling terminal insulation may hide a small amount of powdered calcium oxide that signals corrosion. You may have to peel insulation back and look carefully to find it, but not everyone does. A little bit of corrosion hasn't historically been that big a deal, so it's easy just to give it a quick look, or no look at all if you're under time pressure. But today, trucks are full of sensitive electronics that can be impacted by any little change in voltage. Corroded terminals can cause many types of concerns, including a voltage drop on engine control modules and sensors, which can cause an engine to overfuel, which can accelerate plugging of a DPF, which can trigger the after-treatment control modules to try to fix the problem with more dosing to clean the DPF, which accelerates the plugging. Throw in a lousy cleaning process, and it doesn't take long before we've wrecked another $1,800 DPF filter. And we're probably left cursing the DPF filter. Maybe we should be cursing corroded batteries. Maybe the new normal is that we have to be much more on top of things now. Perhaps the new technology is fine, and the real problem is that we just haven't nailed the process of correctly maintaining it yet. Earlier this year, we started a project to see if we could find ways to reduce after-treatment and maintenance and repair costs. The good news is that we now absolutely believe it's doable. In fact, we think the cost increases we're seeing could be reduced by as much as 80%, some feel more, with improved maintenance processes. Seems the maintenance processes just haven't caught up with the emissions technology changes yet. Not in the shops, and not in the published guidelines. To get costs back under control, we're going to need to up our maintenance game. Strong electrical current matters more now. Clean air in an engine matters more now. Clean fuel matters more now. Application matters more now. And increasing tech training and development to better handle the new technology matters now more than ever. It's safe to say that no matter what issue we're tackling, the future is pointing towards a need for a higher level of diagnostic and troubleshooting skills across the board. We'll need to get better at understanding not just how the new component technologies work, but of how they work together. We'll have to be able to effectively utilize service information, but also know its limitations. Mastering a wider range of critical electronic diagnostic and troubleshooting skills will help us, and a new generation of powerful electronic diagnostic tools is perhaps arriving at exactly the right moment. In many ways, these tools make things easier. They're looking at multiple components and systems simultaneously, offering instant access to diagrams and schematics that will help us troubleshoot by pinpointing areas of potential concern. You just need the tools and the know-how to fix it right the first time. But while the new tools will give us a lot of help, we also need to dust off some of the older proven diagnostic methods that have become more important again. One of our trainers was recently called upon to help with an engine problem. The engine in question would start up, then immediately shut itself down again. It was throwing an ECM low voltage code. But the digital multimeter showed that voltage was fine during a cranking voltage test. The tech was stumped. The manufacturer was stumped. Our trainer pulled out an oscilloscope something shops may have available but often don't use much, and discovered that for 20 milliseconds, the starter had allowed the battery voltage to drop below the minimum threshold, and that was enough to fail the enabling criteria for the code. The digital multimeter only measured to 100 milliseconds. They replaced the starter and it was fixed. The bottom line is that after 2 days of analyzing, diagnosing, and replacing parts, the right person with the right tool decoded the problem in less than a half an hour. We saw the same thing recently on an injector problem. A tech with the right diagnostic tool and skill fixed the problem in 10 minutes that had stumped others for 4 straight days. Technology, the maintenance, and the repairs aren't necessarily getting harder, but the changes are coming at a faster pace, which makes keeping up with them hard. One thing for certain, those who've mastered the critical skills will be the masters in the future of shop productivity. And that brings us back to the importance of this organization, TMC, and the importance of programs like SuperTech. TMC is all about identifying, defining, and above all, sharing best practices. The combined wisdom and experience in this room is staggering to think about, and yet here it is, together in one place because of TMC. And SuperTech is where the learning process gets put on steroids. Thousands of techs studied regionally to try and get here, perhaps up to 8,000 or 9,000 by some estimates, preparing in a myriad of ways to be counted among the industry's best. Not everyone made it, but each one learned more in the process. Companies are increasingly supporting SuperTech because they know that those that make the effort to be here, whether they end up in this room or not, care about being counted as professionals and about being the best at what they do. And we can add you student competitors to that list. We know you're the future, and we know you are anxious to be recognized for being at the top of your game, too. This event recognizes and rewards our successful tech professionals, but it also pushes the boundaries of what's possible in technical training, shop productivity, and service quality. You are the cutting edge in driving change and professionalism for the entire industry. Congratulations to those of you who came here to compete, and good luck to each and every one of you. No matter what, the fact that you're here, the fact that we're all here, means we've already won as an industry. Thank you.